Hello, everyone, and welcome back to this weird corner of the internet where I'm apparently recording my PhD research. I'm probably FX, and the reason this video exists is because I'm studying for a PhD in a post-ChatGPT world, and I figured the best way to demonstrate that I haven't just been doing all my work, research through ChatGPT is to record it as it goes. And there are probably other ways, but this is the output of that particular path. Now, today I'm going to talk about something that I feel may be contentious among cybersecurity professionals, and that is that well, if I'm going to put it in a polite way, that the applicability of CVSS scores are not really relevant in the modern world, and if I'm trying to be contentious, then I'll just say CVSS is a garbage metric. Now, we need to do a few things first, and let's break those down. I might actually zoom this in so it's a little easier for people to see. So, what we need is to know what CVSS is. And honestly, that will answer most of our questions, so we could just dive into that. But let's ask, why is it not applicable? And then we probably want references. Let's look at log4j because that had a score of 10. I think Heartbleed was a high score too. But we can check into those later. Let's look at what CVSS is first, and I think to do that, we can just pull up. I just pulled up my browser, and naturally Google is here with its handy AI summary. What is CVSS? Okay, but yeah, CVSS is a fairly standard vulnerability scoring system that breaks everything down into CVEs of between 0 and, or 0.1, I guess, and 10.0. When generally this score is not like a gut feeling, it has a standard measurement, and this is actually a very good way of getting to know the basics of it. Oh, and some history, that's cool. So V1, 2, or 3.1. So there have been some updates. That's pretty good. See this conclusion. CVSS improves security by helping you find vulnerabilities, and that's true. I'm not going to argue with that. That's technically true. This is a good resource. We're going to copy it into the text file. But while we're here, I'm going to first switch to a different search engine because Google AI is bothering me. I'm sure I could disable it if I wanted to log in, but I don't. And then we're going to pull up a CVSS score calculator because there is a relatively good one which actually helps you understand and break down the metric scores. So you have all these exploitability metrics, attack vector, which is how the attack actually approaches the system, complexity. Honestly, I think complexity should be a bit more of a granular scale than this because they have complexity low, specialized access conditions or circumstances don't exist. And then this requires conditions beyond the attacker's control. And that's like, I don't think that's granular enough because if we look at something like log4j, log4, actually, we will go into log4j later, but it was exploitable by pasting a simple string where we have the complexity extremely low. Everyone was able to do it. And then you have attacks that require a bit more nuance, but still don't require situations beyond the attacker's control. So I might disagree with that one, but maybe not. It all comes down to the attack in question. But yeah, how this calculator works is you just determine network high privileged was required none, so you don't need any kind of user account. User interaction required none. The scope is one I fail to understand quite a bit, so let's see if I can figure that one out. Exploited vulnerability can only affect resources managed by the same authority. So it's basically talking about the ability to pivot. So, for example, if you exploit a system, you can then move to a different system. So if we're looking at something like a domain controller for Active Directory, like the main Windows system that controls other systems in a network, I guess we'd have scope changed, whereas if it's just attacking one component, the scope is unchanged. And then let's put it as a high. Then you have the impact metrics, which is how it deals with the overall score of 9. How can I get it higher than that? Oh, I put high attack complexity. Yes, we got 10.0. Perfect score. Obviously, that's a terrible thing to happen. We don't want a 10.0 anywhere. And you can see even with lower impact, if it has a high impact on 2 out of these things of what we call the CIA triangle, which is confidentiality, integrity, and availability, you'll still get a score of 10.0. But temporal score metrics are interesting because most CVSS ends here. Like CVSS, this is CVSS, the base score. I don't think I've ever seen temporal score applied, but temporal score is actually where you get the level of nuance that exists in the world. So no exploit defined, but we could say unproven that an exploit exists, mitigates it slightly, and the functional exploit exists. I honestly don't know why that would mitigate it compared to not defined. Not defined automatically assumes the worst, but to me a functional exploit existing suggests it should be higher, so maybe people disagree with the temporal score metrics, but temporal score metrics and I guess the environmental score metrics are a way to add nuance to the base score, which I feel like I don't really see all that much. So we're going to put the calculator in our notepad and we'll switch back over there. So we know what CVSS is, and if you've ever seen an exploit, you'll understand CVSS. You'll have seen scores of 10, you'll have seen scores of 8. Now, the next question is, why is this not applicable? And for this, we want to look into the case study of, let's say, log4j. Now, log4j was a interesting attack given its simplicity. Let's look for I mean, we can start with Wikipedia and just talk about what it is. So, log4j, log4shell, we should open that one too. Log4j is a logging library for Java. Java is a programming language, as I'm hoping most of you know. I mean, it's not a problem if you don't know it, but it's one of those things that I assume people looking at cybersecurity things on Twitch are interested in the technology enough to know that. Let's talk about log4j. So yeah, standard logging level system. You have off is no logging, fatal is the highest severity of actual logging, and debug and trace dump out so much information that they basically become unusable as logs. They become all noise and no signal. So we typically want to set a logger in these four. We want info, we want warnings, we want errors, we definitely want fatal. But all of these are inclusive. So info, at least I assume they're inclusive. I think they are in Python. I haven't written code in Java for about 15 years, so I assume these are inclusive. So info should give you warning, it should give you error, and it should give you fatal. Now, log4shell was the vulnerability in November 2021. The exploitation of it was relatively simple. We could go through this. It was doing some string substitutions, and because of that, you could put in an arbitrary lookup. So you could use this JNDI, which is like a let's actually check what Java JNDI is, because I'm not fully familiar with the term. It keeps defaulting to Google as my search engine of choice. I'd much rather it use DuckDuckGo. I should figure out how to configure that. Java naming and directory interface that allows applications to look up data and resources, such as database connections and configurations, using names. So this is the crux of the exploit, because then they were able to include this part of the string, and we'll actually break this down so that we can just have a little bit more here. So what this is then the JNDI, which is the lookup. Which connects to probably an official name for this. You'll actually recognize a more common version, which is HTTP, which is Hypertext Transfer Protocol. LDAP is a... I just realized I'm not showing my notepad, so let's switch over to that. Yep. So this is a... The JNDI is a lookup, and it's telling it to look up this address. Now, this is... I wonder if it's like a protocol designation. If that might be the official name, you'll notice a more common one is HTTP, which designates Hypertext Transfer Protocol. LDAP is a kind of authentication and identity management system, which I don't actually remember. The Lightweight Directory Access Protocol is the definition of this, and then it uses example.com, but I think using example.com is a bad practice when it's not actually indicative of what's happening. So what you would actually want to put here is, say, let's leave the original for posterity, but what you want is attacker server and then payload. So this is forcing it to look up LDAP instructions from this area, and now you can have a LDAP server, which is it's a protocol to query access information typically. So if you have it load from LDAP a payload that says you are a highly privileged user, then you can see that being a problem. Let's go back into the browser and take a look. So you specify an arbitrary file. My headset just made a noise, and I'm not sure where it came from, so I guess we'll figure that out later. So yeah, you pull an arbitrary file that will load data from the URL. You can then use that to load and execute malicious code on a public system. Even if execution of data is disabled, the attacker can still retrieve data, so they may be able to get they may be able to put the environmental variables in the URL and then extract them. There's all kinds of other protocols they are using to exploit, which is kind of interesting. And then it talks about early mitigations, blocking anything that contains the external resource lookup, which it was a valid mitigation at the time. Now, the reason we're looking at this is because this is an exploit that I think... one second. I'm going to take this moment to try and configure my default search engine. To something a little less Google shaped. Okay, so if you're looking here, you may see that there's a sea shanty that was looked up in my recent history. If you're wondering why that is, go to the channel Mind the Blep. You'll figure it out. Okay, let's take a look at the CVSS score for okay, so how bad it is, so act fast. This was, at the time, it was considered 10.0 out of 10. And then it's... This is actually one of the problems here. We have a vulnerability that gets mitigated, and then the actual designation changes. Let's see if we can look into that. Because I have a vague memory of it being 10.0. Yeah. What the 10 means on a CVSS score and why log4j was such a big deal. This is... I don't know if it's one of the most reliable sources, but it at least backs up what I remember. CVSS scores range from 9 to 10. But I should also look into those pages that suggested it was a lower score. We look at this one, we can see... Wonder if these have historical data. Ah, here we go. Base score. But see how what I said before stands? There is a base score listed here, but they are not using the temporal score. They're not using the, what was it, the transmissive score or environmental score, which I guess talks more about the... Seems like a lot of doubling up, but to me the temporal score would be a good thing to include. But yeah, base score 10, critical. So this is the problem. And I want to look into this through two methods. I want to ask how many systems are running Java, because Java actually handily tells you 3 billion devices are running Java. This Reddit post claims it's 56 billion, so I would like to see a source for that. This might be more interesting, the State of Java Ecosystem report. Will it actually let me download a PDF without putting information in? It will. Most used Java versions in production. Most of them are using Java 8. That's kind of fun. Oh, 2024 Java 17 is starting to pick up. But in 2022, Java 8 was still rolling. That's fun. I guess it's reached end of life now and 11's phasing out. It's interesting data. I'm going to dump this into my document just in case. But this is not giving me the information I want, so let's see. If we look at the market share of programming languages, well, so I don't need a search assist, I'd rather look at things, but 20 most popular languages. Oh, and Statista is usually good if they'll let you actually look at anything. So now this is to me a bit misleading because I would personally divide them into front and back end languages. I wouldn't put HTML and CSS, sorry, front end developers. It's not that I think they're not cool. 1 second, I'm just going to have to moderate that chat out of my channel. That's fun. Okay. Well, that's that taken care of. It was probably completely meaningless, but it's fun to do anyway. So, okay, so here we have languages. We have... How do these percentages even work? Because JavaScript is 62%, but HTML is 52%. Like, you can use multiple languages in different projects, but this doesn't give me a clear market share. So it's most used programming languages among developers. So I think here we're talking about something else. I think what we want to look at is, okay, let's go to the next one. I wonder if my university will give me access to that. I am again doing premature research, so I don't have all these accounts set up yet. So key takeaways from this: Python is still the most popular language with an 8.72% increase. Java moved up, but is still, well, it's still behind others. Let's have a look. It will be table comparison, yes. So Python's up, C, Java, and C++ are all relatively close, but they're not, like, they're close to each other. They're not approaching Python. That's the change rate. So yeah, so Python is up considerably. Oh, Rust's all the way down here. I know there are lots of people who like Rust, but apparently it's 1.47% of the world. Also, like, I would be curious if there's anyone watching this. Do you consider SQL a programming language? Like, it's a query language. It's literally in the name, structured query language. It's not designed for programming. It's designed for the querying of data. So, But here we see the problem I'm trying to illustrate is Java is 10.6% of the market share of programs written worldwide, and log4j was a metric score of 10%. The most of the internet that Java can then theoretically have hit is that log4shell can theoretically have hit is 10% of the internet. The highest base score of 10.0 was applied to an attack that was able to be targeted at 10% of the internet. Like, that leaves us nowhere to go. Let's go back into my notepad. Actually, yeah. Let's pull up a drawing tool. I like to draw, why not? Hey, it's my stuff from last time. I'll actually save this so I can add it to the... So I can add it to the... Cool. So I can add it to the GitHub for the previous episode. Now it would be nice to be able to delete everything. You think there would be something to make new? No? Reset the canvas? Yeah, sure. Okay, so I'm actually going to pull out a different browser. There is this thing when it comes to networks called the OSI model, and the OSI model is a 7-layer model, which I'm going to illustrate by slowly drawing 7 boxes. And these are simple. We're only going to fill in a few. We have application layer, we have presentation layer, session, transport, data link. Oh, network, be quite right. Okay, I'm apparently going to fill in all of them because blank boxes will hurt my brain. Now, these are the layers that make up all interconnected systems. It's actually the OSI, the Open Systems Interconnection Model. Now, transport. I'm just double checking some facts. Hmm. So, okay, here we're looking at the different layers of systems. The application layer is exactly what it sounds like. It's where your program is stored, which means it's 1/6 of a, not exactly 1/6 and 1/7, but it's one small part of a system of connections. So you have your program here, and this is a small subset of written in Java. Also here, because you have your program, you have other things which are application layer, which is perhaps how it's communicating, so HTTP. Then you get to the various presentation layers, which are more about the actual networking, so TCP/IP is somewhere. Basically, the TCP/IP model is covering several of these from, let's change my model, covering several of these from here down to maybe here. And then we have data link and physical, and data link are things like the encoding of light being sent through fiber optic cables, and then the physical is the actual electrical impulses. I'm sure you can find better explanations on the OSI model on the internet, but the whole point I'm trying to make here is that this is a tiny subsection which had a potential 10% impact and somehow was ranked 10.0. And this is actually the reason I think CVSS is a useless metric. And let's go back to my notepad. CVSS is not useful because of a few things, and they are CRA, NIS2, and other legislations. Now, we have the cyber resilience and NIS2, which is what? Network information security 2. Not remembering the exact names of those, they don't really matter at this point. What does matter is that these are EU legislation, which have required several things, one of which is the implementation of national information security centers in each member state. Now, CVSS is a lightning strike metric. CVSS measures one thing. It measures how likely it is that you will be attacked. Under the circumstances that you are running the vulnerable software and a vulnerable version with a valid attack method. Now, hands up in the audience who knows Fermi estimation. Now, Fermi estimation is the idea of the order of magnitude estimation to get a relatively accurate measurement with very little information. And I really like the general example is how many piano tuners are there in Chicago. And then you extrapolate from that, 1 in 20 households have a piano. How many of those households are they regularly tuned? How many people are there in Chicago? Divide that by the number of pianos, divide that by the number of who have regular tuning, and then determine how many tuners you need to cover an area of that size. And I think this is fascinating. It's actually been applied to the chance of extraterrestrial life, which is something you might dive into if you're ever bored on the internet at 3 in the morning. It's a quite interesting rabbit hole. But it looks a lot like this. It looks a lot like CVSS is Fermi estimation for security, which is, it's helpful in a way. It's helpful if you are running Java. But as we know, 90% of connected systems are probably not, given the 11% market share. And I don't expect the 11% to be fully accurate. There will be varying numbers, but the point is, Java is one of the popular languages, but it's one of 5 that make up about 60% of the market base. So, and we actually do know that most of the internet is still PHP, I believe, because it's something like a third of the internet runs WordPress, and that's like built on PHP. So we have this problem that CVSS doesn't measure. It's like I explained at a conference once that it's the danger of being stabbed. If you are stabbed, it is very bad for you, but you are unlikely to experience that just walking out of your front door. The issue then we have with CVSS is, in this case of Log4Shell, which was a 10.0, it didn't affect 90% of people. How do we then react if, say, a vulnerability with HTTP is discovered and it starts to affect everyone? We have nowhere to go. We have no finesse. We have no room to maneuver. And there's also this other one that I do want to look into because it's my favorite thing to discover. Let's see if I can find it. Okay, this one. Having some trouble finding this one. Let's check if it's this. No, I'm pretty sure it was this site, but a different writer. Is it .com? Yeah, it looks like it. Yeah. Oh, this is the one. This is my favorite piece of shocking reporting on the planet, I think. And that's saying something with everything going on. We don't have the details yet, but we can safely say that come November 1st, everyone, and I mean everyone, will need to patch OpenSSL 3.x. That sounds terrible, doesn't it? At the time of writing this, 3.x was not the prominent version of OpenSSL. It was the prominent version in the latest release of Ubuntu, which had come several months before. I don't know who patches to new versions of Ubuntu immediately, but yeah, everyone was still running OpenSSL 1.1.1. And yeah, here we go. At first, it looked like OpenSSL 3.x was going to be truly awful, and it turned out not to be so bad. And then they make all these excuses why their original blog was valid, when it's like, no, the common version in use was 1.1.1 and 1.2. But notice how they haven't really changed their old page at all. They haven't done what a journalist should actually do and just write in the headline here, sorry, I was wrong, and done. They just, this is all still here. This fear mongering is still right here. And then in a little page of an update, by the way, we were wrong. Sorry. But they don't actually apologize. They label it OpenSSL dodges a security bullet. So even when they're wrong, they have labeled it as an attack on the people who they falsely accused in the first place. So again, this was cited to be a very high severity issue, and it turned out it affected practically no one because no one was running OpenSSL 3. It was relatively new. And yet, over here, we have Checkpoint. Well, that's a useful link. So 2014's Heartbleed, which was we could actually look into Heartbleed because it was quite interesting. It's rare that an exploit gets its very own webpage. Yep, let's make sure those are off. So it was a bug in OpenSSL's implementation of transport layer security. Transport layer security is what provides this little, you can't see it on my screen, that's less helpful. If you go to your address bar, you will see a lock icon next to it showing you that your connection is encrypted. TLS provides that, essentially. So we can see it led to a leak of memory contents in bidirectional communication. It was leaking secrets, primary key material, which is the encryption keys themselves. So this is a serious vulnerability. And this, I believe, was ranked 10.0. SSL covers a huge portion of the internet. You can probably look into that. And I say SSL, but SSL and TLS are used interchangeably. So let's look at, they shouldn't be, TLS is the more modern version. SSL by default covering 43%. Let's Encrypt, oh, these are just certificate usage. I'd like to, or system usage, I'd like to see, wow, this website is diseased. Let's see if we can do this. Well, we can see HTTPS is growing. Percentage of page loads over HTTPS, so we're seeing it's close to 98% in the US. That's pretty cool. 98 7 in France, 95 in Russia. But, you know, a lot of countries here are well into the 90s. So you can see a bug that affects something like TLS is going to affect a huge portion of the internet compared to a bug that only affects Java, which is going to cover the 10% we discussed earlier. And this is why CVSS is lightning strikes. And the two standards require people to care about things larger than lightning strikes. We need to start thinking in terms of, let's say, coverage per country. So when there is an exploit that drops and it's a severity of 10 via CVSS, we need to know in real time what that means for the cybersecurity posture of any given country, or the country in which the National Cybersecurity Center is operating. And this is why these two legislations matter. These two legislations are what's actually pushing these forward and requiring the National Cybersecurity Centers, which are now looking into metrics to more accurately measure these. And there are some things we could do. It might actually be possible to scan IP ranges to figure out how things are operating, but that would require like scanning massive portions of the internet with some kind of attacks that might be problematic. The other way is we can take the statistics approach and say that Java is covering 10% of the systems. So when I'm actually not going to get into the proposed ideas to cover this yet, because that's a discussion on its own. What I'm looking at the moment is that I want proof that CVSS doesn't make much sense. Let's just Google that and see what comes out. This is actually interesting. This is from Tenable, why you need to stop using CVSS for vulnerability prioritization. Tenable put out software like Tenable Security Center, Nessus, it's a vulnerability scanner. And Tenable actually have, I'm not just going to say Tenable do, because a lot of companies are doing this now, where they have weighted metrics. And they basically take the CVSS for any given exploit and apply things like the temporal scoring that we saw earlier, and they create this weighted metric. And that weighted metric is actually how likely you are to be hit by it and how you then need to prioritize things. Here, even as long ago as 2020, we had Tenable saying CVSS scores do not reflect the current threat landscape. And that's actually true. That's entirely true. The problem is, Nessus have this VPR, which is their vulnerability priority rating. Every other company has one of their own, and they're all proprietary metrics. They're all designed as a sales tool for selling the platforms, and that's the thing that's the advantage that CVSS has over any of these. Is CVSS is designed to be an open, known, transparent system, and everyone else who has invented these, attaching them to programs such as this, is trying to use them as sales fodder. And well, that actually gets into another area I want to cover at some point, which is why security has to come at a premium. Because, well, people don't want to invest in security because it's expensive, and it remains expensive for various reasons. I don't know if that's something I want to weigh in on at this point, but it could definitely be a research effort to figure out why that is. But you can find these weighted scores on a number of tools, and they're actually very cool. They're very good. They work really well. But if you ask them about it, and I have specifically asked Tenable what goes into their weighted score, they will be like, it's proprietary. We can't tell you. And as a security professional looking into security tooling, the last thing I want to hear is you can't explain to me why, that you can't tell me why something is happening. And I realize the world's getting more comfortable with that because that's how a lot of AI tooling works. You get a result, but it can't explain why it's arrived at that result. So I don't think there's much more to say on this subject. These seem like here we go. Base metric out of 10. Temporal scores reflect changing remediation scenario around the vulnerability. See, that's actually kind of cool. And I feel like I've never really seen them in play. Let's look at NVD, which is the National Vulnerability Database. Again, we just have base scores. We have base scores for everything. We don't have a single temporal score. So even though it exists, it's never, in my opinion, used. And someone here, the CVSS should be modified to go higher than 10. I don't disagree. Let's check out this publication, which is the CVSS implementation guide. Nice. This is going in the document. Now I'm going to read through this entire 34-page PDF silently while doing nothing else. No, I'm going to read this offline, but this is interesting. Ooh, it has examples. That's nice. Appendix, I like it. Suggested scoring template. I feel like this is quite old. Do we have a date? Quite old. Let's see if we can find an up-to-date one. Oh, I guess this is the up-to-date one. But that's the 2.0 standard. Let's see if we can find the 3. Okay. So here we have 3, which includes the temporal metrics. The influence of temporal metrics has been reduced. Interesting. Scoring guide, glossary of terms. So let's add this to the document as well. So yeah, here we have the problem. This is why I put the clickbaity title, the CVSS is a garbage metric, because it doesn't really work in the way it's intended to. As we've seen, I'm going to copy the ZDNet. Oh, I've already closed it. I'm going to find it again. This one. I didn't close it. I'm going to put my favorite page here because it never fails to amuse me with its fear-mongering and then still accusatory rectification. It's like, this is journalism in the modern age. And yeah, so as we've seen, CVSS metrics, they don't matter unless you are in a position to be affected by it, at which point I'd like to believe you can get by without a CVSS metric as long as you have information on the exploit. CVSS metrics help people who aren't in a position to understand the exploit well enough themselves to make decisions, and that's absolutely fine. But it shouldn't be used in this blanket coverall system that it's basically holding together right now. And on that subject, I'm just going to scroll up on my notepad to show on my to-do list. I am planning on setting up a GitHub repository so that the output of these research sessions is available somewhere. I haven't got around to that yet because I still haven't started my studies, so I'm allowed to procrastinate for the next couple of weeks. But eventually all the links, all the illustrations, and various notes will be available. Yep, other than that, I don't have much more to say on this subject, but I'll be coming back to research some of the alternatives at some point. If you were either here or found this video later, I hope you enjoyed it and learned something, and I think I learned something too, which is that this approach is not going to help us going forward, which maybe is something I knew before, but it's nice to have some citations to help back it up at this point. Thanks for joining me.